In this video, I would like to explain how to balance a chemical equation using matrix algebra, especially using our graphing calculator TI-83 or 84. Balancing a chemical equation is needed because it has to satisfy the law of conservation of mass, which states that in a closed system, matter is not created or destroyed, so it has to be balanced. Atoms present in the reactants are merely recognized into different arrangements in the product, and also the number of atoms of each type on the left-hand side of the equation must be the same as the number of atoms of each type on the right-hand side. So in order to balance a chemical equation, we always check whether the total number of atoms is the same as on the right-hand side is the same as the number of atoms on the left-hand side. This is mainly because the equation should satisfy the law of conservation of mass. There are various methods to write a balanced chemical equation. The first method is by inspection. The second one using algebraic method. Maybe here in this video, I would like to explain how to use TI-83 and 84 to get the balanced equation quicker. So the first method for balancing a chemical equation is balance by inspection. Let us see how to balance a chemical equation by inspection using an example. So when we are trying to balance the equation, first of all, we have to identify the reactants and the products. Let us assume that the reactants are the propyl alcohol and oxygen. And the product is given as carbon dioxide and water. So I can write the unbalanced chemical equation, which is CH3, CH2, CH2OH plus O2 yields, that is the arrow mark, carbon dioxide CO2 plus water H2O. So in the third step, we are counting the number of atoms on both sides. If I'm taking carbon, the left hand side is 3, right hand side is 1. Hydrogen, left hand side is 8 and the right hand side is 2. Oxygen, the left hand side as well as the right hand side are 3. So we have to decide the order of atoms to be balanced, and also we have to pick the elements within the compound. So for hydrogen, carbon, everything we have to pick. So when I count the number of atoms here, and also if I want to balance the types of atoms, on my left hand side I have to balance 3 on the carbon. The left hand side I have got 3 carbons. So my right hand side also I should have 3. To balance hydrogen, the first one I have got 7 hydrogen plus 1, so that is 7 plus 1, 8 hydrogen. So on this side, on my right hand side, if I multiply by 4, then it is balanced. 4 2s are 8, so that is balanced. When I'm trying to balance oxygen, it looks like on my left hand side, there are 4 oxygen here, 3 2s are 6, so altogether 10 oxygen. So if I want to balance that on my left hand side, here I have 1 oxygen and here it looks like I have 2. So if I multiply by 9 by 2, then this becomes 9 plus 1, 10. So that's how we adjust those constants. So in this case, I have 9 by 2. It is better to avoid the fractions because conventional balanced equation with integers only is delivered. So we desire to have a whole number. So if I want to have that as a whole number, I have to get rid of this 2. So if I want to get rid of this 2, I multiply this by the whole thing by 2. The both right hand side as well as my left hand side, the complete equation must be multiplied by 2. So since I'm multiplying every term by 2, this becomes 2. 9 by 2 times 2 is just 9. 3 2s are 6. 4 2s are 8. So the balanced equation is this. So the one what we tried here in the beginning, the first method, is just by inspection. So it is just trial and error. You cancel out, you balance the equation. So it is a little lengthy. Maybe if the balanced equation is a little simple, then it is easy to do by inspection. If you have complicated one, maybe we can do that algebraically. The second method of balancing a chemical equation is doing that algebraically. So in an algebraic method, you can do the same problem and get a balanced equation. Let us make use of the same example here. So when we do algebraically, the step 1 and 2 are the same. We are assigning some unknown coefficients, constants A, B, C, and D. Like in my previous case, if I'm trying to balance and compare the number of atoms on the left hand side and the right hand side, we get this list here. So taking this as an algebraic equation, my 3a must be equal to c, 8a equal to 2d, and a plus 2b equal to 2c plus d. So by solving for a, b, c, you can get the value for a, b, c. A is your b is 9 by 2, d is 4, and c is 3. So in order to avoid this 9 by 2, you multiply throughout by 2 and you get the same equation as in the previous. Multiplying throughout by 2, you get the same equation as in your previous case. Now the same thing can be done using our graphing calculator. So the third method of balancing a chemical equation is using matrix algebra, especially using a TI-83 or 84 graphing calculator. So the initial conditions what we did in the second step is the same. We are taking some unknown constants A, B, C, and then we are trying to get some systems of linear equations. So using this TI-83, 84, we have to consider the augmented matrix and enter that in our calculator. How will you enter the augmented matrix in the TI-83 is pressing second x inverse. Second x inverse will give us the matrix, and you can edit whether it is a 3 by 4 matrix or 4 by 5 matrix, etc. In this case, it will be a 3 by 4 matrix, and you can find the reduced row echelon form using this key, whatever I have showed here. So in our case, see this matrix is 3 by 5, so writing the coefficient and the constant, the augmented matrix, and then taking the reduced row echelon form, this is what I'm getting. So this gives me the value for A, B, and C. A is negative 1/4 of D, and B is 9/8 of D, and C is negative 3 by 4 of D. So we have to pick a value for D. D is a variable quantity. You can take any value for D, but this reduced ratio, the coefficient should be balanced, and we have to get the simplest form of it. So if I'm trying to get the simplest whole number here, the smallest one, if I'm taking D as 8, then I'll get the value for A, B, C. A will be 2, B will be 9, and C will be 6. So when I substitute those values here, this is what I'm getting. I'm getting this A, B, C, D becomes 2, 9, 6, and 8. But usually instead of writing this as a whole, it's better to reduce this as 2C3H7OH plus 9O2 leads us to 6CO2 plus 8H2O. So this video helped us to understand how to balance the chemical equation. We saw 3 different methods. We just did this problem just by inspection. This equation could be balanced by inspection. However, we had different approach using algebraic method and using the graphing calculator method. Hope this video was helpful in understanding how to balance the chemical equation easily and quickly using our graphing calculator. Thank you for watching and thank you for listening.